Hello, everybody. Welcome to the webinar. We're just giving everybody about 2 minutes to start. People are still signing in, so please stay tuned. Hello, everybody. Welcome to the webinar. We're just about to start in a minute. We're just giving people some more time to sign up. Hello, good morning, everybody. Welcome. Good morning, good afternoon, good day, good evening, wherever you are. I think it's time to start. Most people have signed up by now. My name is Alexander Ox. I'm Director of Climate and Energy at the World Watch Institute, and I'm the chair of the LET's Global Partnerships Energy Working Group. Together with my colleague Sandra Cano from the Asia-LET's Partnership, we're leading you through this webinar. We're very happy to have you. We have a very good turnout. A lot of people signed into this webinar. This is the first in a three-part webinar series. That's what the Let's Global Partnership is for who haven't joined us at earlier events. This session is on long-range energy alternatives planning, on the long-range energy alternatives planning system, a tool that's called LEAP also. And we have one of the developers presenting this tool to you. And we're then hearing from two case studies, two countries, Vietnam and Indonesia, that have actually used this tool, and give you some insights, share some insights with you for how they use this tool successfully. Resilient energy planning. We're doing 3 web in this series. There's one on these tools and how they have been used. To do more webinars that present other in particulars. Just before I introduce you to the agenda, some that you understand that open doors are specific products or services. We should to them information Here is a slide on some housekeeping items. You have two or listener. You can either
Muted.
on the right-hand side of the displays. And if you select that, a phone number and a PIN will display. Just a reminder to our panelists today to please mute your audio device when you're not presenting. Otherwise, we will hear the latest chit-chat from you and your colleagues. So please make sure that you unmute your phones when you're not presenting. If you encounter any technical difficulties, then please contact the GoToWebinar help desk, and you see the number here in front of you, 888-259-3826, and you will be helped there. So those were the housekeeping items. Without any further ado, here is what we are hoping to do today. After this welcome and my introductory remarks that we are right in the midst of, we will give you a short overview of the Asia-Let's Partnership and the Let's Global Partnership Energy Working Group. I will hand over to my colleague Sandra Cano in a moment. She will present the Asia-Let's Partnership, and then it's me again with a few words about the energy working groups and some highlights and how this webinar relates to other things we're doing. We then have our three presenters, and that's going to be, of course, the core of today's session. Charlie Heaps from the Stockholm Environment Institute will introduce the LEAP tool to you, and then we have Nguyen Minh Bao from the Institute of Energy in Vietnam, and then Saifuddin Swaib from USAID Indonesia, the USAID Indonesia's Clean Energy Development Program, who will present on how they have used the tool and to what results. We then turn to a questions and answer session. I hope we have a lot of time for that. Please see that you have, if you have questions already coming up during the presentation, please type them in the questions or in the commentary in the chat pane on the right-hand side. These questions will be collected, and we will address as many of those in the end of our session when we turn to questions and answers. In the very end, we're asking you to please stay online for less really than a minute, just for a short survey. I think it's 3 questions about how you think we were doing today. We are always trying to improve, so it's very important for us to hear from you. Of course, you can also email us with any additional suggestions. You will find our contacts in the very end of this presentation, of this slide deck, actually. So with this, let me turn it over to Sandra Cano.
Unmuted.
Great. Thank you very much, Alex. Sound check. Hearing okay? Okay. All right. My name is Sandra Cano, and I lead activity planning for the Asia-Let's Partnership Secretariat team. And many of you signed up for this webinar today have participated in prior virtual or in-person activities of the partnership. So thank you, and we're happy to have you. I'll spend just a few minutes talking about what we do. So for context, the Let's Global Partnership is an international initiative that draws support and participation from over 160 organizations whose common goal is to upscale implementation of low-emission, climate-resilient development. The Let's Global Partnership has 3 regional platforms through which it delivers activities. The Asia-Let's Partnership is one of those regional platforms. The Let's Global Partnership also has technical working groups that provide expertise in support of activity delivery, and the Energy Working Group, which is led by Alex, is one of those working groups. So this webinar series that you're on today is a collaboration between the Asia-Let's Partnership and the Energy Working Group. to bring to you all awareness, expertise, information, and peer exchange and sharing on innovative tools for advancing low-emission, climate-resilient energy planning. And this session is our very first in the series of 3 to 4 sessions in all on this topic. We'll be holding a few more sessions in the coming months, so please stay tuned. We'll be sharing information. A little background on why we're hosting this webinar series on this topic at all. Every 2 years, the Asia-LEDS Partnership works with our members to identify regional priorities on which we'll work on together. And for the 2015-2016 period, clear priorities picked by members for the energy sector in particular are capacity building for low-emission energy planning, strengthening know-how on finance mobilization for low-emission measures in the energy sector, and facilitating peer exchange on both of these topics. So we hope that this webinar series helps to do that, to raise awareness on available tools to support you in low-emission energy planning, and brings to you approaches and lessons learned by peers in the region. In addition to this webinar series, the Asia-LEDS Partnership is working on a few activities in 2016 that relate to low-emission energy planning that might be of interest to you. So you'll see some of those activities listed on the slide. For example, we have published a new online catalog of training on low-emission energy planning that contains free quality training. You can find that on our website at www.asialeds.org. We have 2 upcoming events, regional events, designed for stakeholders in Asia that might be of interest to you. One is our annual Asia-LEDS Forum, which attracts about 250 people from 15 to 20 Asian countries. We'll be holding a back-to-back workshop focusing specifically on catalyzing finance for large-scale grid-connected clean energy in Asia. Both of those events will take place in June, the last week of June in Hanoi. So I'll just wrap up. We'll be sending you a follow-up email after this webinar to share a little bit more about some of these upcoming opportunities. We hope you'll continue to participate in our activities. All right, so turning back to you, Alex.
All right, thank you, Sandra. I hope you can hear me. If not, please give me a sign, co-organizers, please. So this was great, thank you. The Asia platform has been a great partner really in many events that we have organized before. Let me say a few words about the Energy Working Group. We are the longest standing sectoral working group of the LEDS Global Partnership. I have the honor to chair it. We are now about 200 experts and decision makers from around the world with different levels, of course, of engagement with us. I'm supported by 3 regional co-chairs from each major region of the LEDS GP, and also Secretariat hosted at World Watch Institute, which is led by Philip Killeen, who is on this call and who I want to thank really for helping us organize today's session. So the Energy Working Group promotes climate-compatible development in the energy sector through a work program that is focused on a few key areas. We're focused on learning, information exchange, and communication of best practices across regions and across countries. We're trying to improve climate-compatible development in the energy sector through advisory services and technical assistance. Trying to be quick responders to technical assistance that we receive from countries all around the world. So if you have pressing questions, we are here to help. And then finally, we hope to enhance opportunities for coordination and collaboration between experts on energy low-emission development strategies. Here are just a few of our highlights from this year's work program. In addition to The new series we're beginning, the new webinar series we're beginning here today. We will also host webinars on low emission climate resilient energy strategies in Africa and in Latin America and the Caribbean. You will find the announcement of those if you join our mailing list, so please let us know. You will have the contacts in the end of the slide deck, and we'll add you to the list of our recipients if you haven't joined us already, or check out the WorldWatch and the Let's GP websites for these additional webinars in addition to this mini-series that we're doing in Asia. We're also hosting or co-hosting energy trainings, for example, at the Asia Labs Partnership Regional Workshop that Sandra just mentioned. We're doing similar events at this year's Africa Regional Workshop. And then we have two flagship or two signature projects that I want to point you to. We are currently developing LED's Sustainable Energy and Development World Atlas that showcases best cases, showcases best experiences from individual countries from around the world. It's an online tool that countries and experts can use to see what others have been doing, how they have been doing it, and what the results of those were, well beyond just the energy realm, so really the development impacts. And then secondly, we're just starting a pilot phase for a LED's community of practice. So this community of practice is a working group, a real working group, not a webinar, not a talk shop, but really we're bringing together experts from around the world working on one specific issue in this pilot phase, hopefully more to add later on. This first pilot community of practice is most likely going to be on bioenergy, and more concretely the case of bagasse, of residual crops, using these crops for residual crops for energy generation. How do you assess your potential? How do you analyze the costs and benefits of alternative pathways? And what are the concrete, how do you design and implement the concrete policies towards the use of the gas? So please stay tuned for the announcement of how you can join the community of practice as well. Today's session has a lot to do with another signature project that we have been working on over the last 2 years, and which we first published in 2015. It's a LED's Energy Toolkit. This toolkit was last published in 2015. It is a reference guide for well-established lab planning tools like the LEAP model that we're presenting here today, tools and methodologies. A focus of the toolkit is on tools that are available to you at no or at low costs, and these tools, this toolkit will be updated and extended. We're hoping to come out with an improved version of it this year. It has been extremely successful. The 2015 version shows 18 different tools, and you can find this toolkit on the LED's website and our partner website, including the website of the WorldWatch Institute. We hope to feature new tools in this year's case. So if you have tools, if you're a developer yourself, or you know of great tools that are not yet showcased in the Energy Toolkit, then please let us know that as well. So what is the toolkit? I had to promise Charlie that I'm not going into the content of these slides that you see here right now. I don't want to steal his thunder, of course. It's really just to give you an idea of what to expect from the toolkit, an overview, what you're getting if you're looking at it. It's in a PDF format, so everybody can use it very easily. What we do in it is really just present tools at a relatively high level, but still to an extent that you get an understanding of how these tools might be helpful for your work. So we provide a screenshot, as you see here on the left-hand side, and then we are giving you some information about who would be typical clients of each individual tool, who actually have already used the tool, who have been current and past users, what are the costs if you want to use the tool, and where to find more information, how to contact the people actually running the tool, or the developers of the tool who can help you with their application. There's 2 more slides here, but in reality this is really just 1 page of the toolkit. So you see this here in front of you. We're then on the 2nd page providing information to what exactly is the tool, what are its key goals, and also, what data you need to run the tool and what you can expect from the outcomes. So it's, as I mentioned, at a relatively high level. This toolkit is supposed to introduce tools and methodologies to you for planning of LEDs in the energy sector, and hopefully it has been used by many before. It has been quite successful, so we're very happy about that. And actually, the idea for this webinar came out of this toolkit as well. So this was it from me. Let me briefly introduce our first main speaker for today, my dear friend Charlie Heaps, who has been active in the Energy Working Group, attended many of the LEDs workshops before and presented the LEAP tool there. So today you get a chance to hear from him. Charlie is a senior scientist with the Stockholm Environment Institute. He's one of the developers of LEAP. LEAP is really a leading energy and environmental planning tool used in hundreds of organizations and dozens of countries of the world. Charlie also manages Command, a web-based community for energy planners in developing countries. He has developed a range of other software tools, so he's really one of the leading guys out there. So with no further ado, over to you, Charlie.
Thanks, Alexander. Having some trouble unmuting there. Good morning, everyone, or good afternoon, depending on where you're sitting. Thanks for the introduction. I hope you can all hear me. My name's Charlie Heaps. I'm the developer of LEAP, and I work for the Stockholm Environment Institute, which is an international non-profit research organization working on sustainability. SEI is based in Stockholm, but I'm actually working out of the US office, which is at Tufts University just outside of Boston. What I'd like to do this morning, if I can do it quickly enough, is give you a brief introduction to LEAP, just give you a brief overview of the kind of the structure of LEAP, tell you a little bit about where it's been used, then spend a few minutes actually demonstrating some of the screens, so showing you just a sort of hint of some of the capabilities of LEAP. I won't have time to give it proper justice, but I'll do my best to show you at least a few of the more interesting screens. And then just a couple of slides just telling you where we're going with LEAP, some of the things that you can expect to see happening in the coming year or so. So let me get started if I can get PowerPoint to work for me here. I hope you can see my screen. So before I start on LEAP, just a brief introduction about SEI. So SEI, again, Stockholm Environment Institute. Basically, we do sort of 5 different things. One is that we're the main developers of LEAP, and we develop and distribute LEAP. LEAP is available at no charge to students worldwide and to universities, government agencies, and non-profit organizations based in developing countries. So that's one of our key activities. We also do a lot of work training people to use LEAP and generally building capacity amongst government and other agencies to help people use LEAP. As Alexander mentioned, we also manage something called Commend, which is basically LEAP's website, and it's a web-based community of LEAP users. It now has over 29,000 members in basically every country in the world, and I'll tell you a little bit about how we're revamping that in a minute. And we also do our own scenario studies, and I might mention some of those in a minute. And just this screen here is just showing you some of the recent workshops we've been doing. The one on the bottom right was in the Philippines, and I can't remember where the other ones were, but they're all recent applications. So just a brief overview of LEAP. The idea of LEAP is not so much to be the most sophisticated model in the world, although we like doing sophisticated modeling, but really the key concept in LEAP is to try and take a relatively complicated topic, which is sort of energy planning and low emission development planning, and to try and make it as usable as possible. And the way we've tried to do that over the years is to build something that's sort of easy to use, it's very graphical, it's very scenario based, so it helps you tell stories and evaluate stories, and it lets you look sort of holistically across all the different aspects of doing low emission development planning. So it focuses primarily on the energy sector, but it lets you also think about both energy demands and supplies, and also non-energy sector sources and sinks of greenhouse gases. So it lets you sort of do a comprehensive evaluation of energy and non-energy sector greenhouse gases. And it lets you look at various different dimensions of the problem. It lets you think about sort of what's going to happen to sort of energy itself. What are going to be the primary energy requirements of your scenarios? What's the sort of energy security implications of your scenarios? But also, what are the costs and benefits of various different options? So, is one scenario better in terms of capital costs, but another scenario might be better in terms of fuel costs and operating and maintenance costs? And then, of course, it also lets you look at emissions. So it keeps track of emissions for all greenhouse gases, and it can also be used to look at air pollution as well. So not just greenhouse gases, but also air pollutants like black carbon, particulates, methane. So increasingly people are using it to look at short-lived climate pollutants, SLCPs. One very important point about LEAP is that it's not a model of a particular system. Think of LEAP as a piece of software that you can use to build your own models. And most people are using it at the national scale. So most people are using LEAP to build models of a particular country. Increasingly, people are using it at other scales as well, though. So people are beginning to use it more and more for doing city-level modeling, or they might be using it to do regional planning. And I think we'll hear about that from some of the other speakers in a minute. It has been very widely used now. It's been, as I say, it's been used in almost every country in the world, and it's been very heavily used both for national communications, and also by a number of countries have used it to help formulate their INDCs that were recently presented at the Paris conference of the UNFCCC. A couple of other capabilities to mention, but I won't go into a lot of detail. One of the nice things about LEAP is it's fairly flexible. So you can start out in situations where you don't have a lot of detailed data. You can get started with relatively simple data, but then you can use different methodologies depending on what kind of data and expertise you have available. So the idea in LEAP is not to have sort of one fixed way of doing things, but it's rather to sort of be fairly flexible so that it can support different data situations, but also support different kinds of methodologies. So those methodologies range from sort of very simple kind of accounting practices where basically just you are using LEAP much like you would use a spreadsheet to sort of construct a set of accounts and then tell a story about how your energy system is going to evolve over time. That would be kind of the sort of simplest way of using it. But if you have the data available, you can do fairly sophisticated analyses as well. So you might choose to go all the way up to doing, full-on least cost optimization modeling, where you're actually getting the software itself to calculate what's the optimal configuration of a system. Basically telling you, how can I configure the system in the future to deliver my greenhouse gas emissions reductions at the least cost. Now, one other important thing I'll mention is what we call the API, the Application Programming Interface. So that's a system that lets LEAP talk to other models and be part of a wider software system. So you can use that system, for example, to connect LEAP up to the integrated benefits calculator that we're currently working on, which is a tool for looking at the avoided impacts associated with short-lived climate pollutants. So you can actually calculate things like avoided mortality or avoided crop losses from scenarios that are looking at reductions in air pollution emissions. Or you can use it to do things like risk assessment through Monte Carlo modeling by connecting LEAP up to some of the standard tools out there like Crystal Ball. So those are just some of the capabilities. Here's the basic structure of LEAP. So you can see it's, I think it's fairly simple in terms of the structure. All of the LEAP models start out with an energy demand analysis. So that's where you look at sort of the consumption of energy in households, industry, transport, services, agriculture. That analysis drives your transformation analysis. So transformation is where you think about things like electric generation, oil refining, charcoal production in developing countries, those kinds of things. So you're basically building a complete model of how energy flows through an economy, and then you're using that to tell a story about how that system might change over time. So energy demands will grow, possibly because of population growth or economic growth. But at the same time, you can be looking at things like energy efficiency or switching to renewables that will help reduce the growth in primary energy demands, and will also help reduce emissions of greenhouse gases. So hanging off the side here, you have your calculation of GHG reductions. And then also hanging off the side, you have the ability to do integrated cost-benefit analysis. So I won't go into any more detail at the moment, but that's the basic structure of LEAP. Just a quick mention of some recent activities. If you, lots of activities going on at the moment. Lots of people will be using LEAP. A number of studies have recently come out or about to come out about LEAP. There's a few of the covers of those studies there. Please visit the LEAP website if you want to read some of those studies. Most of them are available there. And I should just mention also that at least 31 countries have used LEAP to help formulate their INDCs recently. Okay, so what I'd like to do now is quickly switch over, because I'm rapidly running out of time, quickly switch over and actually show you LEAP in action. Now I hope you can see LEAP on screen now. I just want to show you a few of the capabilities. I haven't got time to show you the whole thing, but just a few of the capabilities. So what we're looking at here, for example, is some of the results that come out of LEAP. So here we're looking at the results view in LEAP and looking at total energy demand over time, organized by fuel. So this is the kind of thing you can calculate in LEAP. And you can see it's very flexible. You can look at results in all sorts of different units. You can reorganize the results if you don't want to look at it by fuel, but if you want to look at it by sector, you can do that kind of thing as well. So here's energy demand organized by sector. And you can look at all sorts of different results. So here we're looking at energy demand, but we might also choose to look at total greenhouse gas emissions. So here's our baseline or reference scenario over time showing greenhouse gas emissions and how they're going to grow over time if we don't take any policy action. We can also construct alternative scenarios. So for example, here I've pre-calculated a mitigation scenario. So you can see we have different emissions in different scenarios. And LEAP is also very good about helping you to sort of compare results between scenarios. So for example, I could look at what's the difference between my mitigation scenario and what have I avoided versus my baseline or reference scenario. So here's a typical result where we're looking at the colored in bars are the actual emissions in your mitigation scenario, and the dotted line above is what you avoided relative to your reference or baseline scenario. So those are the kinds of results you can get out of LEAP. You can get hundreds of results out. You can even sort of make animated charts that show how things change over time. LEAP is also very good about doing different data visualizations. Let me just show you a couple of them. So one very important one, which is important for energy planners in particular, is the energy balance for a country. So here I've switched over to show you the energy balance, and this is like a snapshot of how energy flows through a particular country in a particular year, and it's a kind of report that would be very familiar to anyone working in the energy ministry. that data can also be shown in the form of a Sankey diagram. So here's a Sankey diagram that's automatically calculated for the country that shows you sort of interactively and dynamically how the energy is flowing through a system. You can see here's our primary fuels coming in, here's crude oil going into a refinery, you might have some losses, some of it might go into your electric generating system, here's all the losses in the system, and here's all the final demands down here. And then let me show you a couple more charts. So I'm going to switch to a different data set over here for the European Union, which we calculated a while ago. So this is a slightly different kind of data set in that it actually has regions built into it. So this is a set of results that actually not just for one country, but actually for multiple countries. You can see over here the regions are the names of different countries. When you're looking at these kinds of results, you can either show results for the whole region that you're modeling, or you can show results individually for particular countries. So you could use that kind of feature for a model of multiple countries, or you could use it for a model of one country divided down into regions. And I think some of the panelists later on will mention that they've been doing more of that kind of approach. So this kind of model can also be used to show results in the form of a map. So here, for example, you can see results where we're looking at greenhouse gas emissions per capita for different countries within the European Union at different points in time and within different scenarios. Okay, let me just mention a couple more things. I think I've got about another 5 minutes. I also wanted to mention very quickly how the scenario management works in LEAP. So in LEAP, one of the very key ideas in LEAP is that the data management in LEAP is all oriented around the idea of helping you sort of manage your data and tell stories about how things might change over time. So let's have a look at a very simple example of that in our sample data set, which in LEAP is just called Freedonia. So here we have our scenarios in LEAP. So here you can see we start out with a set of current accounts data, which is basically what our base year data looks like. And then we can have a baseline or reference scenario. And then we can make alternative scenarios that look at, what's the impact of introducing different policies. So here we've got little sort of individual sort of mini scenarios that are just looking at particular measures. So here's one for efficient lighting, here's one for efficient refrigerators. And then we can combine those together into an overall mitigation scenario. So one of the nice things in LEAP is you can actually sort of plug little mini scenarios together to make an overall integrated mitigation scenario. And then you can sort of plug and unplug them and play around with what are the pros and cons of different measures and how best to combine them into an overall mitigation scenario. That's a very simple example of it. Let me show you a slightly more sophisticated one. Here's a model that we developed for a US state recently for Massachusetts. And you can see here we have a very complicated set of scenarios. We have a baseline scenario. We have, I think, maybe 40 or 50 different individual mini scenarios. Those mini scenarios are packaged together. So here, for example, we have a transport package that combines lots of little individual transportation measures. And then down here, we have an overall mitigation scenario that packages the overall sectoral measures together. So it's very easy to sort of package things up and to try out different combinations and permutations of options. Okay, and I just want to show you one more screen in LEAP. So one other nice feature in LEAP is this idea that you can you can show your results to your stakeholders and actually let them interact with the model. So I'm going to show you this overview screen in LEAP. So this is a screen where you can actually explore different scenarios and actually change them on the fly. So you can see here I've got two scenarios, but initially I've got a baseline scenario and a mitigation scenario. And down in the bottom you can see various different indicators of that scenario. So this chart is showing me the overall greenhouse gas emissions. This chart here is showing me how my energy security changes over time, so how dependent I am on imports. And this chart here is showing me the overall costs of the scenario. I'm sorry it's a little bit squeezed up because of the screen space. But what we can actually do with this is we can actually pull some of these levers over here and change the scenarios on the fly. So let me try doing lots of industrial efficiency and see what that does. So I'm going to pull this lever over here. I think I have to refresh the screen after I do that. It's recalculating. It's very quick in recalculating LEAP, and now you can see it's recalculated the scenarios. So now just by pulling that one lever, I've managed to create a new scenario where I'm reducing greenhouse gas emissions. So I'm having an impact on energy security. In fact, this measure has actually reduced energy security, and you can also see, it's rather hard to see. Let me just hide that. You can also see it's had an impact on cost. And in this case, it's actually reduced the overall cost compared to the baseline scenario. So those are some of the screens, some of the capabilities of LEAP. And I know I'm rapidly running out of time, so I've just got a couple more slides to show you. I hope that's all right before the presenters kick me off. So I just want to tell you a little bit about what we're working on at the moment and what will be coming in the next major version of LEAP. Basically what's happening over the coming year. So in terms of LEAP itself, there's basically three main things we're working on, and those will be part of the sort of the next major release of LEAP. And I should say that when we release a new version of LEAP, that's always free to all of the users. You know, it's not, you're not locked into using the old version. So the first major feature we're adding is new capabilities for modeling energy storage. So energy storage is really becoming increasingly important, especially when you're considering sort of scenarios that involve sort of deep integration of variable renewables. So things like pump storage, batteries, flywheels, all those things are likely to be very important in the future for helping to integrate very high penetration of variable renewables. So that's something we're working on, allowing you to model that well in LEAP. The second thing we're working on is a public release of this new tool, which combines LEAP with a benefits calculator that actually lets you look at the avoided impacts of measures to reduce short-lived climate pollutants, SLCPs. So it actually will calculate things like, you know, what's the mortality avoided, what are the crop losses avoided from measures that reduce SLCPs. That should be released somewhere around the middle of this year. And then finally, we're working on improving the energy water nexus modeling in LEAP. So LEAP can already be integrated with SEI's WEEP model, which is a water resource planning model, and we're doing another phase of that to make it a more powerful tool. So that's what's happening with LEAP. The second thing we're working on is a major revamp of the LEAP website. So the LEAP website is very popular. It has 29,000 people, but frankly, the interface is now rather out of date. So we're working to make it responsive, so that it'll work on any device, phones and tablets and PCs. We're adding features to allow people to interact much more deeply with each other and really promote interaction and you know, sort of deeper community interactions on the website. And there'll be new features for sharing data and searching for data that other people have shared. And then finally, we're also working on a new cloud-based technology database. So this LEAP has always had a technology database built into it, but frankly, it's obsolete at this point. So what we're doing is moving that database up into the cloud, and you'll be able to contribute data to that or draw data out of it. It'll be free, it'll be open source, and it won't just work with LEAP, but it'll work with a range of different models. We're going to sort of publish an application programming interface so that any model, whether it's LEAP or Marcal or some of these other models, so that they can all talk to this database and extract data from it. So that's what's coming with LEAP. Let me just give you a brief hint of the website before I go on. So here's just sort of a couple of the beta screens that we're working on, just so you get some idea of where the LEAP website is going. And I think I've run out of time, so I'll leave it at that and give someone else a chance to talk. Thanks.
Okay, Thank you very much, Charlie. I think that was a very useful overview for everyone. We're going to keep the Q&A part to the end, but in the meantime, if anyone listening in has a question, please type and submit your question through the question chat window that you see on the right-hand side of your screen. So without further ado, I'd like to introduce our first country case presenter, Mr. Nguyen Minh Bao. Is a senior researcher of the Center for Renewable Energy at the Institute of Energy in Vietnam. He has over 10 years experience using LEAP, such as for development of greenhouse gas mitigation scenarios in the energy sector for Vietnam's second national communication to the UNFCCC in 2010, as well as for Vietnam's INDC submitted recently in 2015. So Mr. Bao, may we ask you to begin? Thank you.
Okay. Good morning or afternoon, everyone. Let me give you a presentation on application of LEAP for INDC in Vietnam. The main content of my presentation will focus on explanation on how LEAP was applied and how LEAP present was used for INDC, and what are challenge and solution, and finally some recommendation. For introduction, as you may know that in order to prepare GHG reduction commitment for 21st UNFCCC conference in Paris 2015, all parties required to devise the intended nationally determined contribution. Vietnam had prepared INDC to determine possible mitigation target at national level, covering all renewable sectors such as energy, agriculture, land use chain, and forestry and waste. For Vietnam case, we used LEAP for determination of GHG emission reduction potential in energy sector. Next slide, please. Next slide, please. Okay. The question is why LEAP was selected for this project. Currently, very many types of models can be accepted and used for mitigation analysis, such as the MACAR and PEP and LEAP. But we selected LEAP as a tool for INDC preparation in Vietnam because of the reason. Firstly, LEAP was primarily designed for integrated energy and GHG mitigation analysis. LEAP was thoroughly tested and generally found to be credible. LEAP has been widely application for more than 190 countries worldwide, and many countries selected to conduct the report to UNFCCC. Other modern like PEP and MACAN require a great number of data, but LEAP can be used with a low initial data requirement. Next slide, please. Next slide, please. Okay. LEAP is a accounting framework that can be easy, verified, and highly transparent. LEAP is a simple tool that makes it easy for users to develop different policy scenarios and select the best solution based on cost-benefit analysis. LEAP is a flexible, can be used to create models with different energy systems based on the data available, ranging from bottom-up to top-down approaches. LEAP can be used with low level of data requirement. It's important, LEAP is a free of charge for the developing country. And finally, we have a considerable experience on using LEAP. Let's play, please. How LEAP was for INDC in Vietnam. The objective of INDC is to analyze mitigation technology and then determine the possible GHG reduction potential that can be adopted by the country. To apply LEAP for INDC, we follow the step. Firstly, identify existing policy, national priority, especially the possible GHG mitigation technology. Then select methodology, develop baseline scenario, develop mitigation scenario, and select prioritize mitigation technology based on economic benefits and GHG reduction costs. And finally, propose the possible mitigation contribution of energy sector. Next, please. For the methodology, we use the bottom-up methods because we can use the detailed data on fuel technology and policy. We can assess cost benefit of individual technology and policy, and it is easy to verify and highly transparent. But the constraint of this method is the data limitation. To overcome this constraint, firstly, we propose a long list of possible mitigation technology. Then we select the technology with available input data based on the previous study. Next. In order to develop a mitigation scenario, it is important to distinguish between BAU and mitigation scenario. The BAU scenario was developed based on the input data such as change in overall economic output or GDP growth, change in population, change in technology, with assumption on the lack of additional policy in response to the climate. Then GHG mitigation scenario was developed based on the potential of renewable energy efficiency technology with assumption on the on more additional policy and action plan to respond to the climate change. To develop mitigation scenario, firstly, we need to set up the list of mitigation technology like the energy efficiency, renewable energy, fuel substitution. Then create the suitable framework of energy system and calculate the cost, benefit, and GHG potential. Next. Contribution of energy sector to INDC. In terms of contribution of energy sector to tie up prioritize mitigation technology could be categorized. Firstly, unconditional contribution. That means the technology can be implemented by domestic resource. Second is the conditional contribution. That means the technology can be implemented with additional international funding, technology transfer, and capacity building. The selection and categorize of this technology based on the criteria for the unconditional contribution. The technology should be low abatement cost, already implemented in Vietnam, aligned with sectoral plan. For the conditional contribution, the technology could be high abatement cost, new technology, and currently implemented in developed country. Next. It is important is how LEAP result can be adopted and applied for INDC. The result of LEAP needs to be analyzed and adopted by policymaker, management, and representative from ministry. Therefore, they should be invited to involve in this study at the beginning of the project. They also participate in the series of meetings to check the data input, assumption, and fully evaluate output result. Then the draft report, when the draft report was finished, we sent it to energy experts, both international and in the national level, to get comment. Then the final report should be submitted to ministry and branches to get comment. And then final report was submitted to Prime Minister to get approved. Next. Challenge and solution. Firstly, is input data. There's still inconsistent on data and information from the different sources. For the solution, we analyze and select the suitable data based on the reference sources with a priority ranking, such as public data from National Statistics Yearbook, officially public document from ministry, public research result from institutes. And finally, we organize group meeting to analyze and select suitable data. The second is inconsistent data in base year to NU approach. When energy consumption was broken down by subsector and NU for the NU approach, the result was the inconsistent compared to origin base year data on energy consumption by fuel. For the solution, we create more other EU to put the remain of energy consumption for each sector in the base year. Next. Conclusion and recommendation. Firstly, conclusion. LEAP is a very flexible model regarding data requirement. LEAP is a suitable model for energy mitigation analysis in the developing country due to data limitation. LEAP is a good choice for assessment and selection of GHG mitigation technology in energy sector because of the simple verification and high transparency. Second is the recommendation. LEAP is just a tool. The user should have background of good knowledge on the related work that require LEAP to support. The beginning at LEAP model should be practice calculation with simple model of energy system, and then extend more complex energy system. Learning by doing and practicing, that is the best way to get step-by-step experience on using LEAP. Thank you very much.
Okay, thank you very much, Mr. Bao, for sharing with us your process for making the decision to use LEAP and how it's been used in Vietnam. So now I'd like to introduce our next case presenter, Mr. Saifuddin Suab, also known as Sipu. He is currently working as the Low Emission Development Strategies Planning and Monitoring Evaluation and Reporting Specialist as part of the USAID Indonesia Clean Energy Development 2 program. He started using LEAP in 2012 to assist Indonesia's Energy Working Group in developing the subnational greenhouse gas baseline emissions for provinces in Indonesia. Sipu and his team have also completed a LEAP starter kit for use by provinces of governments in Indonesia to support development of provincial energy plans. So Sipu, please tell us a little bit more about your work. Thank you.
Good morning, everybody, and then good evening, Charlie. I know it's almost 12 a.m. there. My name is Saifuddin Suab. You can call me Chipu, and then I am from USAID Indonesia Clean Energy Development Program. And then today I'm going to use my 10 minutes wisely. So I'm going to present about the application of LEAP to support greenhouse gas emission calculations in the energy sector in Indonesian provinces. Next slide, please. Okay. The first question is why LEAP? My answer is why not? We in Indonesia, we're using LEAP due to various reasons. The first one, because LEAP is suitable for GHG mitigation and energy planning, and then those are two policy streams that is currently ongoing in Indonesia, because we have the so-called National Action Plan for Greenhouse Gases Emission Reduction and also National Energy Planning. So those are two streams that is very suitable with what LEAP is doing. And then the second reason is it is more simple compared to other models, and then it means that it is easier to learn and then less data requirement. The third reason is like free for developing countries. Well, we like free stuff, and then since Indonesia is still as developing countries, we think it is also, because since it is free, it is suitable for regional planning, because local government can access it for free, and then they can learn the LEAP by themselves. And then the last one, Indonesia actually has the largest LEAP users across the globe. We have currently almost 2,900 users, which is account for almost 10% of LEAP users across the globe. So it also means that once we are going to develop GHG mitigation planning at the subnational level, we will have so many available users that we could ask to contribute to the subnational planning process. Next slide, please. Okay, I can see now. Sorry. So the first activity that I'm going to overview is the developing of GHG emission baseline for 34 provinces in Indonesia. The legal basis, because we have presidential regulation in 2011 that mandates the review of existing subnational GHG mitigation planning. When this mandate comes out, it means that we have to review the baseline that we have done in 2016. And then for this we have done the GHG mitigation planning at subnational level in 2012, and then now we are required to review it. So that's why we are going to do it in 2015 and 2016. And then this activity is coordinated by RAN-GRK Secretariat. So it is the National Planning Agency for Greenhouse Gases Emission Reduction. And then in this work, USAID ICE, my office, developed the starter kit. Means that we have to develop database and also LEAP structure for the provincial governments, especially for the energy sector calculations. And then after we developed the database and LEAP structure, we also conducted training in 3 different regions in Indonesia. For your information, Indonesia has 34 provinces right now, so we don't think that it is going to be effective if we are doing the training like for the whole 34 provinces at once. That's why we divided them into 3 different regions. The West regions covering Sumatra and Java Islands, Central region covering Kalimantan, Sulawesi, and Bali provinces. And also in the Eastern region, we have Nusa Tenggara, Maluku, and Papua. So if you're not familiar with those 3 provinces, just open the map and then see how many provinces that we have to cover. And then since LEAP is currently used by the government Ministry of Energy, the trainers for this activity included the staff or the officials from Ministry of Energy and Mineral Resources, and also from USAID Indonesia Clean Energy Development. So this is just the pictures, the trainings that we did in 3 different regions in Indonesia. In a region in Belitung, in Central region we did it in Solo City, and for the Eastern region we did it in Makassar City. So the next question comes like, how does this activity inform the policy? So the business as usual emission resulted from this training will be the basis for updating each province's GHG mitigation plan, or we also know it as RAD-GRK. And then at the national level, as Charlie mentioned earlier, that LEAP also has the feature of multi-region feature. So in Indonesia, we also try to assemble the whole models from 34 provinces and then unite it in one national LEAP that consists of 34 provinces. It allows the national stakeholder to monitor the level of projected emission in each province based on this baseline scenario that we did. And it also allows the national stakeholders to see, like, in each province, which mitigation actions that should be prioritized according to their baseline emission level. And we hope that the sub-national LEAP model could be the province's starter kit to further develop their sub-national energy planning. Because in Indonesia right now, our national energy planning will be promulgated soon, within this year. And then once it is promulgated, it means that the provincial government will have the mandate to develop their subnational energy planning. And then I think the LEAP model, the starter kit and LEAP database that we developed could be the starter kit for them to start developing their subnational energy planning. Yep. The second activity that I'm going to present is the LEAP for the national energy planning. Previously, we have the national energy policy that states the energy target for Indonesia. You can see in the table what we are going to achieve in 2025 and 2050. Yeah, it sounds mission impossible, but we are trying our best to achieve it. And then in order to achieve this target, we need a model that we think suitable to that can provide us, like, what will be our annual achievement that is realistic in order to achieve this target. And then that's why we are using LEAP. It is selected as the tool to model the national energy policy targets. And then during this process, we are doing participatory process. So we develop LEAP model, and then after that we present it to the national energy stakeholders, and then they will provide some more insights. And then because we're using LEAP, since it is very flexible, it's very easy for us to change the parameters and everything according to the insights or feedbacks from the national energy stakeholders. And then Planning Bureau and the National Energy Council lead the modeling and drafting process of our national energy planning. Can we go next? Yeah. How does the activity inform the policy? Sorry. Yeah, the LEAP result is the basis to draft the narrative of Indonesia's energy planning, and then it is also used as the tool to present the national energy planning to various energy stakeholders. So since LEAP also could have a very good interface, that's why, like, it is very easy to the national energy stakeholders to understand the tables that we present when we use LEAP. Now, I'm going to mention several challenges that we encountered during our activities. The first activity is the sub-national GHG mitigation plan. The first challenge is provincial data is the main issue, because the database is still a problem, not only at the national level. Can we? I mean, we can imagine if we see at the sub-national level how hard it is to obtain the data, and that's why we from USAID start developing the STAR kit for the local government. And then our second challenge is actually from the capacity building perspective, because the training that we did is continuous. Unfortunately, there is also a continuous government staff rotation. So we have to sometimes retrain someone from the basic again, even though we have trained maybe their colleague who have to be shifted to the other position. And then for the sub-national GHG mitigation plan, the time allocated to finish the plan is very short. While for the activity 2 for the national energy planning, again, data is the main problem. Some activity data is not available at the national level, particularly for commercial sector and industrial sector. And then the second of all, various stakeholders with conflicting interests. So once we present with, let's say, stakeholder A, they will mention something, and then the other stakeholders, when we present this to the other stakeholders, they will state a conflicting opinion. So those are the things that we have to work out. And then the last one is political process. And my next my last slide will be the next slide. Yeah. Sorry. Can I go back? Okay. Now, the overview of LEAP in Indonesia in general, it has been used at national and subnational level, and also it becomes the inputs for the national and subnational policies. And then, however, LEAP application in Indonesia still focuses on supply, demand, and emission projection. So when Charlie mentioned least cost optimization, we haven't really used that since it is quite hard to attain the costing data. So we haven't really used optimization feature that actually LEAP has. And then I heard that LEAP also tried to be, we tried to link LEAP with the other applications, and one of it is WIP. And then we know that Indonesia actually has so many hydro potentials, but unfortunately in Indonesia, not many attempts to use LEAP and WIP application yet. So our recommendation may be like for future LEAP training in Southeast Asia, if any. Now I hope Sandra hear this. It should cover optimization exercise and also maybe LEAP and WIP applications. How the link of these two applications. And then, like currently in Indonesia, we are also trying to electrify the remote area or the small islands that have no electricity yet. So we want to see if there are some users who have combined LEAP with the other models for rural electrification purpose. This is just my idea. So I think that is all for me. Thank you very much.
Thank you very much, Mr. Sweep. If I could ask the organizers to share my screen again. All right, here we go. I'm going to leave this slide open so that you can take note of it. Thank you very much to all the presenters. Thank you, Charlie, for a great overview of LEAP, what it is, and I believe you convinced us that in fact it is a very sophisticated tool, if one that is easy to use, and we're looking forward to the new versions of LEAP that you announced and the new products. Thank you also to our two country presenters, Mr. Bao from Vietnam and Mr. Sweep from Indonesia, sharing insights from their individual country environments. We now have about 17 minutes, well, we want to leave a minute for the survey at the end, but about a quarter of an hour for the Q&A session. We already received a few questions. I'm going to moderate those and ask the presenters to answer them to the best knowledge. If you have more questions, please make use of this opportunity, and you can do so by typing your questions in the question pane on the right-hand side of your pane. Before we're starting with the questions, I want to make sure that we thank you for participating. We hope that you will join the Let's Global Partnership. You see on the screen in front of you now the websites of the Asia Let's Partnership, as well as of the energy working groups, the two links. Through those links, you can find also membership forms for how to join us. And please contact us with any suggestions for improvements you have, any questions you have after the session as well. So now I'm trying to find the questions here. Okay, I've got them here. Let me still see whether I can show my screen. Okay, here we go. Perfect. One question was just relating to, is the software free? Somebody might have missed the introduction from Charlie or from myself. The toolkit features mostly tools that are free or at low cost, and Leap is a software, so that was an easy answer. There are quite a few technical answers that I'm not able to answer, so that really goes to Charlie. So let me read a few of those, and Charlie, maybe you can take notes and then answer them. I'm going to bundle a few. One question is, where does solar PV fit into the Leap software? So for example, if we assume that the data is available, can Leap then estimate the effects of solar PV displacing other resources? That's the first question regarding PV in the Leap software. A second one is just a technical question. On what computer platforms does it run? Does it only run on Windows, or does it also run on Windows for Apple? What computer software or what computer hardware does the software Leap run on? And maybe a third question for this first round, also going to you, Charlie, would be that given the low data requirement of Leap, which is clearly a benefit as we have learned, how reliable really are the results, and how does that compare to the results of other models? So maybe we start with these three questions. First, what platform does it run on? Specific question for solar PV, and then how do the results compare to the results of other maybe more sophisticated but also more complicated models? Charlie.
Okay, thanks, Alexander. Well, so the first question about where does solar PV fit in? Well, I mean, in some ways, Leap is sort of technology agnostic. So, you know, solar PV is sort of just one of your potential options for generating electricity. So you'd basically fit it in as one of the sort of possible electric generating technologies you have available. But obviously, solar is not the same as, you know, fossil power plants. So when you're thinking about solar, you know, it has, you want to think about the availability of that. Same with wind, you know, there's going to be different seasons and different times of the day when it is available and it's not available. So obviously it's important to model that within Leap. And the way you do that is you sort of divide your year up into time slices. So your slices might be sort of times of day or different seasons of the year. And you can say, you know, what's the capacity of the solar plants that you're going to build? How much do they cost, but also when are they going to be available? So obviously they can be available during the day, but not during the night. And one thing I would say is that the current version of Leap is not very good at modeling energy storage. And once you start getting to sort of high penetration of wind and solar and other intermittent renewables or variable renewables, that's going to be important to model the, you know, how storage can sort of flatten out the difference between demand and supply. So for now it's not so good at that, but that's something we're working on, and the next release of Leap should have much better capabilities for modeling energy storage. Now in terms of platforms, I'm afraid that it is at the moment only a Windows-based tool. You can run it on a Mac with some fiddling. In fact, I'm running it on a Mac now when I was showing it to you. But usually the way to do that is to run it in a virtual machine, either VMware or Parallels, or there's some free VM tools. So it is possible to get it running on a Mac, but I don't advise running it purely on a Mac. You know, it's best to run it within a Windows environment, because once you do that, then you can have Leap talk to all these other useful tools like Excel and Word and PowerPoint and, you know, various other Windows-based models. Then third question about how reliable are the results? Well, yes, you know, we were talking about, oh, it's great, you don't have to put much data into it. But really, with these models, you kind of get out what you put in. So you can make a very simple model in Leap, but you won't get a whole lot of insight out of doing that. So, you know, as the models grow, as they start to sort of look at into more detail, then you can do more things with them. You know, so for example, you could build a model where you only divide each sector down by fuel. You don't have to, you know, because it's a lot of work to try and generate like an end-use based model where you're actually looking at sort of, you know, what kind of technologies are available for cooking and lighting and refrigeration. and so you don't have to do that. You can put in some very simple data, but obviously then you won't get much insight into, what if I've got a mitigation policy where I'm thinking about the possibility of doing energy efficiency in refrigerators and lighting, unless you've got some detail in your model describing refrigerators and lighting, then, you're not going to get much out of it. So it's really kind of, like everything in life, you get out what you put in. So, and the same is true of LEAP. I hope that answered that question, not too vaguely.
Thank you, Charlie. I like your comparison to real life. That's good. Let me ask you a second set of questions from the audience. That these questions also go to you, and maybe you can take notes again, and we bundle a few of them. In the last round, the question was also how does it compare to other models? So maybe you want to say a few words about that. How does it compare to alternative models? Questions also, if the results are somewhat different, other ways to standardize them. How would you recommend the use of different models for LEDS planning in one specific country, say by country leads? That from your experience, are results often, do they differ a great deal, or how do you deal with that? That would be one question. Another one would be, can the tool be used also for city level implementation? So is it would you rather say it's a national tool, or can it be used at different levels of political organization, sub-federal levels, also maybe regional levels beyond the nation state? So that's a second question. A third question is how can people learn to use the LEAP tool? Is there a tutorial? It looks very simple to you as a modeler, but let me tell you, if you look at it at first, it looks a lot more sophisticated than it looks like. It might be difficult to use. So do you have any tips for how we can most easily use it? And then if I may add a fourth question, you addressed solar PV already before. One of our listeners, one of the participants in the webinar rather, is very interested about bioenergy, so maybe you can share a few words about that as well. So back over to you, Charlie.
Okay, thank you. Yeah, I'm sorry, I didn't really answer the question about how it compares to other models first time around. So I think one of the ways traditionally that models have when I say models, I really mean tools for building models. One of the ways they've differed in the past has been their calculation methodology. So 10 years ago, LEAP was always like, the idea it was a simple accounting-based system where you did sort of, basically what came out of it was what you put into it. So, you describe your scenarios in LEAP, and then LEAP just puts all the pieces together and tells you the results in terms of overall emissions and energy use and costs and benefits. And then some of the other more sophisticated models, like, for example, Marcal or Message, which is the IAEA's integrated modeling tools, those are more kind of optimization based. So they're based on the idea of you basically put in all of the possible technologies into the software, and then the model itself will tell you this is the best combination of those technologies. So they're based on the idea of least cost optimization modeling. So that's kind of traditionally been the difference between them, but this kind of the strength of LEAP was always that it was relatively easy to use. The other models were more sophisticated but much harder to use. And then kind of over time things have merged a bit. So LEAP does now do optimization modeling. It doesn't do full energy system optimization modeling. It only does optimization of a particular sector. So it can tell you the least cost electric system, but it can't automatically tell you what's the least cost combination of demand side energy efficiency and supply side capacity expansion. So those are the kind of things you can still do in Marcal that you can't do in LEAP. So that would be a major difference between them. In terms of how the results compare, you should be able to get the same kind of results out of both of them. And I don't actually think there's been enough work done to really compare the results coming out of them. A few people have been doing that recently. But they're all engineering-based models, so they all ought to be giving similar results if you put the same assumptions into them. So usually the results differ because you're putting very different assumptions into them. but there's no good reason that they ought to differ in terms of their calculation methodologies. You know, they're all doing something fairly non-controversial. So that was question one. Question two was, can the tool be used at city scale? Yes, it can, and it has been used quite a bit actually, particularly in Southern Africa. There's a number of organizations in South Africa have been using it at the city scale. There's a number of organizations in China who've been using it at the city scale. And we've been doing quite a lot of state level and some city level modeling in the United States as well. So it definitely can be used at that scale. I think where I would pause is that for the most part so far it's been used at the national scale. And I think that's because most countries probably will struggle to find enough expertise to be able to do a lot of modeling at the city scale. But I do think that's increasingly going to be important. And I think I still have to do more to make LEAP easier to use, because I think it's kind of set up for people who are energy planners or even people who have an interest in modeling. And I think you're not necessarily going to find a lot of those people working at the city scale, so it's still going to be quite daunting. As you say, Alexander, you know, it's very easy for people like me to say that LEAP is easy to use, but what I mean is it's relatively easy to use compared to some other very sophisticated models, but it doesn't mean absolutely it's easy to use. So I still think we have to do a lot to make it easier to use and make it more approachable for a large number of people. So then your question three was, how can people learn to use it? I think probably most people do still need some training, although I find that people are increasingly picking up the training manuals and having a go at those themselves and making very good progress. Those training manuals are available on the LEAP website, ngcommunity.org. So please go there and, you know, feel free to download them and play around with it. We're also working on a series of like little short demonstration videos where we can demonstrate some of the key sort of things you can do with LEAP in just sort of like 5 to 10 minute sort of YouTube type videos, and that they will be part of the new LEAP website that we're working on. And then of course there can be sort of longer sort of training workshops organized, and we do a lot of those. You know, sometimes we do them through working with organizations like the LEDS Global Partnership, or sometimes with USAID, sometimes with UNEP. You know, a lot of organizations have been supporting those kinds of training workshops. So I would say that the best way of trying to get on into one of those workshops is just to keep an eye on the LEAP website. You know, when we know about a workshop, we will announce it. Please also, if you're interested, join the LEAP Facebook group. I think Sandra's put a link to it in the chat window. That's a very good way of hearing about upcoming workshops, and it's also a good way of just getting in touch with other people, you know, in your region as well. And then the final question about bioenergy. LEAP can be used, you know, LEAP certainly can be used to model sort of bioenergy processes. You can certainly model biomass, both traditional and modern biomass on the demand side. We probably could do quite a bit more with that. In fact, the older version of LEAP used to have quite a sophisticated biomass modeling capability, and we haven't really kept up to date with that. But if that's something that people are interested in, it's certainly something we're thinking about working on in the next couple of years. But it does have pretty reasonable biomass modeling capabilities already. And maybe I'm being a bit vague about the answer because I'm not exactly sure what the question is, but if people want to know more, please feel free to drop me a line.
You ended up on a very good point. We are sharing your contacts here with your permission on the screen.
Please do, yes.
There's many more technical questions relating, for example, to greenhouse gas specific data, a whole host of additional questions. Please, as we're running out of time, please contact Charlie directly with these questions. You've raised quite an interest in the LEAP tool, Charlie. There's questions for when the next training workshops in specific countries can be. So you have a lot of homework to do. Thank you again for all your great answers to the questions. Let me also thank the two country presenters again, Mr. Bao from Vietnam, Mr. Suaib from Indonesia. There have been some questions for you, but really mostly compliments for the great presentations that you have given. And again, the request to share those slides. We are going to share the slides. You will all receive an email from us following up this webinar with links to the recording of the webinar, to the slides, and any additional information. So let me thank you all for participating in the webinar, the presenters, the audience, and now turn it over to the organizers. Please stay online for another 30 seconds and answer our survey. It's a really quick survey that helps us a lot. Thank you all so much, and we hope to hear you again next time. Bye-bye.